For the Chapter 3 test, here's page 2. Page 2 deals exclusively with elimination. Now, elimination is really saying, can you add two equations together to get an x or a y to cancel out? Of course, what we can do is very quickly look and see that our x's, 3x and a negative 6x, of course, will not cancel out. However, if I multiply the top equation by 2, I will get 6x minus 8y is equal to 16. Remember, I have to multiply every single term by 2. The second equation I'm going to leave as it is. The 6x and negative 6x cancel, negative 8y and 8y cancel. There are 0 variables left. 16 plus negative 16 is 0. This is a true statement. When we see a true statement, we can write infinitely many solutions. By way of comparison, if we'd ever get something like 4 is equal to 0 or something like that, that's false. That would be no solution. Take a look at number 7. Again, we could, if you'd like, look at just the x's for a moment and see if we can cancel them out. Adding a 3x and a 9x will not cancel out. But a common multiple between 3 and 9 is 9 itself. So up on top, I will multiply by negative 3, because negative 3 times 3x would get me negative 9x. Negative 3 times 4 would get me negative 12. That's negative 12y. Negative 3 times 6 is negative 18. When you recopy the second equation, you're going to be able to see quickly that the x's go away. You'll have negative 10y. Negative 18 and negative 12 add to negative 30. When I divide by negative 10, I will be left with y equals positive 3. But of course, I have to find x. Look at the original equation. Here is 3x plus 4y is equal to 6. And you can very well plug in your y value of 3. 4 times 3 will become a 12. So we have 3x plus 12 is equal to 6. I will subtract 12 from both sides to get 3x is equal to negative 6. Finally, when I divide by 3, I'll get x is equal to negative 2. It's very important to write your answer as an ordered pair, writing your x and y together. As we move on to number 8, I do want to point out the fact that you could cancel out your x's. You'd have to find a common multiple between 5 and 3, which would be 15. However, if you pay attention to your y's, they're actually very close to canceling out as is. A common multiple between 2 and 4 would be 4 itself. So you need a positive 4 and a negative 4. So I'm going to take this top equation. I'm going to multiply by negative 2. When I do that, I'll get negative 10x. Here we'll get plus 4y equals negative 8. Down below we'll have 3x minus 4y equals negative 6. Why did we do this? Well, our y's have a common multiple now, but they're opposite signs of a positive 4y and a negative 4y. These will cancel out. Negative 10x and 3x add to negative 7x. Negative 8 and negative 6 add up to negative 14. You can divide by negative 7, and you'd get x is equal to a 2. Now, of course, you still have to find y. So we'll have 5x minus 2y is equal to 4. We're going to have to plug in our x value of a 2. And 5 times 2, of course, is 10. We have 10 minus 2y is equal to 4. I will subtract a 10 from both sides, I will be left with negative 2y is equal to negative 6. I will divide by negative 2, and I'll have y is equal to 3. The answer will be 2, 3. As we take a look at number 9, again, you might look at a common multiple between 2 and 4, like we were just talking about. That would be 4 itself. So we could multiply the top by negative 2. Very similar to the work that we did above, except now I'm canceling out x's. I'll have negative 4x plus a 6y equals negative 18. Down below we have 4x minus 6y equals 4. We don't change that equation at all. But look what happens. The x and the y's are going to completely disappear and cancel out. Negative 18 plus 4 is negative 14. And I'm left with this very strange equation, very false equation, that 0 is equal to negative 14. This is truly not true. You'd say there's no solution. Now again, just like in the problem up above that we started with number 6, if you'd get a true statement that 0 equals 0 or something like that, that's when you must write infinitely many solutions. Finally, if you look at number 10 on this page, you have an x and an x. They both have 1's in front of them. It's just that a 1x and a 1x won't cancel. Instead, you can multiply the top or the bottom by a negative. I could multiply the top. I'll have negative 1x plus 2y equals negative 14. Down below, leave your equation alone to have a positive 1x plus 6y is equal to a 2. And here the x's cancel out. 2y plus 6y is 8y. Negative 14 plus 2 is negative 12. And I think it's here that kids fear the worst. They fear that they made some kind of mistake. When you divide by 8, it's pretty evident that 12 is not divisible by 8. But you could answer as a fraction or a decimal. And just wanted to encourage kids to look at that fraction button. You will get a nice simplified answer of negative 3 over 2 very, very fast. Now again, you could go to either of your equations, like x plus 6y equals 2, or you could have gone to the x minus 2y equals 14. Honestly, it doesn't matter. Just want to show you you can choose either equation in all honesty. Plug in this y value here. And you can wonder, hey, what is 6 times negative 3 halves? Well, here you don't even really need to type in a fraction button. You can just hit that slash. I wanted to show you that too. You'd get negative 9. So this is x minus 9 equals 2. Add a 9 to both sides. You will be left with x equals 11. So we're dealing with a little bit larger of an x-coordinate than we normally see. But this wraps up page 2.